My name is Jennifer Jordan. I am studying electrical engineering and mathematics at Portland State University, and I am graduating this coming spring.
So, my name is Kathleen Jocelyn. I am actually working on my degree in mathematics at Portland State. And obviously, we are the Open Source Rocket Academy, or OSRA. Currently, I am the Chief Technology Officer. So, that means that my focus is on our actual prototype. So, I'm deeply involved in the research and development of our prototype.
So my name is Teresa Nguyen. I am a mechanical engineering major working on lower division courses at Portland Community College, and I am a sophomore.
I'm Risto Rushford. I am a graduate student at Portland State. I also got my bachelor's degree, Bachelor of Science in Supply Chain Management, and graduated in summer 2019. And I've completed 1 year of graduate studies in systems engineering. I'm about to start my first year in graduate studies of electrical engineering with a focus on signal processing. I've also earned a graduate certificate in computer modeling and simulations, and this next year I'll earn another one in computational intelligence.
So we were inspired to start the Clean Tech Challenge because we have already been working on this project for a while, and since our propellants are IPA and liquid oxygen, they are clean burning and it's environmentally friendly, especially compared to the alternative solid motors. So going through clean tech, we were really focused on the environmental aspect of it, and then working through that program, we came to the realization that that we could actually make a difference by making this technology accessible and building a curriculum around it to make it safe for people who are also going into the aerospace field.
From my perspective, I would say the challenges was like not all of us were on the same page with what it meant to start a business and how to learn that, and so a lot of us were kind of dipping our toes into that world a little bit more.
Definitely had to shift our focus to not just developing the technical side of things, but also develop the educational side of things.
Being very clear on the product that we were selling, and learning how to do it quickly, but to do it that synthesizes all of the information and work that we've done, but to synthesize it into something that's really concise and that you can communicate.
I think one of the biggest ones was obviously COVID-19. Our prototype relies on us being able to be there and work on it in person.
That's been a huge challenge, especially in terms of logistics. We've had to order a lot of parts to be able to build our test stand. And then when those parts come in, we have to be able to assemble things. And COVID has created both the logistical challenge of being able to order those parts from companies. Some of them have not been as responsive as we have hoped, or the lead times are just so much longer than they were pre-COVID. But it's also made it a lot more difficult for us to be able to coordinate, to be able to go in and do the project work directly.
Luckily, we were able to get all of our components and our project to my garage, where I currently am. So it's definitely a little bit of a Silicon Valley.
Open Source Rocket Academy is a startup business that wants to sell our certification curriculum.
We are developing a liquid rocket engine test stand and engine.
We want to provide hands-on experience for people who didn't really, they don't really have access to, that sort of hands-on experience that we've had in the Portland State Aerospace Society.
Investing ourselves in the development of the liquid fuel test stand and other rocketry projects.
And we're also developing the curriculum to teach the design, operation, and safety of the system. So we are solving two problems. We're solving the accessibility to the technology and the environmental impact of the rocket engines. So our liquid propulsion technology is inaccessible. It's not taught in university. The only way that it's taught is through onboarding processes at aerospace companies, and there is no standard. There's no safety outlines, and there's no third-party training available to students or people that are freshly graduated from engineering and going into the aerospace industry. So we are changing that by offering a curriculum, and our technology is also clean burning and inexpensive. So the technology itself is the test stand and the engine, which is this whole monstrosity behind me. So we have these two propellant tanks. One of them has isopropyl alcohol, the other one has liquid oxygen. They move through all of this piping and these different valves, which regulate the pressure, the flow rate, and the temperature. And they exit out of the engine, which there is an ignition system, and it fires, and it's really pretty.
I hope it will make them realize that they're capable of this too, that they have the ability to do this, and that they, if they have a spot to come and learn in a good place, then they can do it. And I hope that it encourages people who may, like myself, who maybe didn't see themselves in the STEM world. Maybe it'll encourage people to, to keep going with it, and to kind of fall in love with rocketry, like we all have.
The mission remains that we wanted to make rocket science accessible to folks who may not have gone to a big name school or had the same access as other folks who've already really been deep in the industry have gotten. And so it was really easy to sign up because we're all very similar mission minded in that way.